Elon Musk just shocked NASA with a plan that could change space forever. SpaceX officially revealed they want to launch 44 Starships per year from Kennedy Space Center, turning America's most iconic launch site into an airport for rockets. This unprecedented move has NASA scrambling to redesign 60 years of operations. The shocking reality: commercial flights face 2-hour delays, air traffic networks need complete rerouting, and the FAA already released hazard zone maps showing massive disruptions. SpaceX spent years conducting secret blast testing and sharing classified safety data with federal agencies. Industry experts are split: revolutionary breakthrough or operational nightmare? Let's dive right in. So what exactly did SpaceX reveal that has NASA scrambling? The answer lies in a 50-page document that reads like science fiction, but is backed by cold, hard data. From moon launches to airport operations, picture Kennedy Space Center in March 2025. Astronauts from the Fram-2 mission are watching a Falcon 9 rocket streak across the sky while heading to their own launch. This wasn't just a cool moment. It was SpaceX showing the world their vision of the future. That vision? Transform America's most iconic launch site into an airport for rockets. Multiple launches per day, multiple companies, rockets launching when ready, not when bureaucracy allows. It sounds impossible until you realize SpaceX has already proven the concept works. Their Falcon 9 rockets now launch every 2 days on average from Florida. That's over 100 launches per year from a single location. Something experts once called impossible. But Falcon 9 is small compared to what's coming next. This is where the story gets complicated. Starship isn't just bigger than Falcon 9. It's in a completely different category. Standing 400 feet tall when stacked, it's the largest rocket ever built. And SpaceX wants to launch 44 of them per year from Florida. The math is staggering. Each Starship launch creates safety zones that could shut down commercial aviation for hours. Florida handles over 1,000 flights daily through its airspace. One Starship launch could delay hundreds of flights, cancel connections, and cost airlines millions. The FAA has already released preliminary hazard zone maps that show the scope of the problem. Aircraft would need to reroute hundreds of miles around each launch. Major airports could face ground stops. The disruption would cascade across the entire eastern United States. So how does SpaceX plan to solve this seemingly impossible puzzle? The answer took them years of secret research to develop. Here's what most people don't understand about rocket safety zones. For decades, government agencies have been guessing. They use conservative mathematical models because they don't have real-world data on what happens when modern rockets explode. Most rockets historically used hydrogen or RP-1 fuel. Starship runs on liquid oxygen and methane. These fuels behave completely differently when things go wrong, but nobody had the data to prove it, until SpaceX decided to create that data themselves. For years, SpaceX has been conducting blast tests at their McGregor, Texas facility. They deliberately explode rocket components, measure the results, and feed the data into sophisticated computer models. The footage they released shows massive fireballs and shock waves, all carefully measured and analyzed. This wasn't random destruction. Every explosion was designed to answer specific questions about methane-oxygen safety zones. How far does debris travel? What are the acoustic effects? How do different explosion scenarios compare to traditional rocket fuels? The results were revolutionary. SpaceX's real-world data showed that methane-oxygen systems create smaller, more predictable safety zones than government models suggested. This data became their key to unlocking Florida operations. But SpaceX didn't stop with controlled tests. They also analyzed every Starship failure, and there have been many. When Starship exploded during early test flights, SpaceX treated each failure as a data collection opportunity. They measured blast radii, debris patterns, and acoustic effects from actual rocket failures. These real-world disasters became scientific data points that support their Florida expansion plans. Only SpaceX would turn spectacular failures into regulatory advantages. The strategy worked. Government agencies began incorporating SpaceX's methane-oxygen data into their safety assessments. The company wasn't just asking for permission to launch from Florida. They were providing the scientific tools to make better decisions. SpaceX revealed another crucial detail that changes everything: timing. Traditional rockets can take days to fuel and prepare for launch. Starship's entire fueling process takes under 1 hour. This isn't just about efficiency, it's about minimizing aviation disruption. Instead of shutting down airspace for an entire day, SpaceX could limit closures to 1 to 2 hours per launch. That's still significant when multiplied by 44 launches per year, but it's manageable. SpaceX points to their Texas operations as proof this works. During recent Starship flights, the FAA reopened affected airspace within 10 minutes of launch. Some areas were cleared in just 7 minutes. No major flight delays. No cascading cancellations. The company is essentially proposing to apply this same rapid clearance model to Florida operations. Instead of the traditional shut everything down for safety approach, they want dynamic airspace management that responds to real-time conditions. This puts NASA in an incredibly difficult position. The space agency desperately needs SpaceX to succeed because Starship is central to the Artemis moon program. NASA has already committed billions to this partnership and can't easily find alternatives. But SpaceX's Florida expansion creates operational challenges NASA never anticipated. For over 60 years, Kennedy Space Center has operated on a simple principle: massive safety zones with infrequent launches. SpaceX wants to flip this model entirely. Internal NASA discussions reportedly show mixed reactions. Some officials see SpaceX's data-driven approach as the future of spaceflight. Others worry about abandoning time-tested safety protocols for the sake of commercial efficiency. The agency finds itself caught between supporting their most important contractor and maintaining the conservative safety culture that has kept astronauts alive for decades. There's no easy answer. Beyond regulatory challenges, SpaceX's plan requires massive infrastructure investments. Launching 44 Starships per year means handling enormous quantities of fuel, power, and logistics. Each Starship launch requires 1,200 tons of liquid oxygen and 300 tons of liquid methane. That's enough fuel to power a small city for days. SpaceX would need to transport and store these quantities safely while maintaining rapid turnaround times. The company is proposing to build additional launch pads, expand fuel storage facilities, and upgrade power systems across Kennedy Space Center. The total investment could reach billions of dollars, fundamentally transforming America's premier spaceport. But here's what makes it economically viable: reusability. Unlike traditional rockets that get thrown away after one use, Starship and Super Heavy are designed to land back at the launch site and fly again within hours. The economics only work if SpaceX can achieve airline-like operations. Other rocket companies are watching SpaceX's Florida expansion with growing alarm. Blue Origin, ULA, and smaller providers all depend on Florida access for their most important missions, and they're worried about being squeezed out. The concern isn't just about launch scheduling. SpaceX's infrastructure investments could fundamentally reshape Kennedy Space Center operations in ways that favor their specific technology and operational approach. Some competitors argue that SpaceX is trying to monopolize America's most valuable launch site. They point out that government facilities should serve all American companies equally, not be optimized for one player's business model. Industry veterans raise valid questions about whether aviation disruptions are worth the benefits. Turning Kennedy into a high-frequency launch site sounds impressive, but it could undermine the careful balance of interests that has made Florida's Space Coast successful for decades. Florida's weather presents challenges that SpaceX's Texas operations don't face. Hurricane season can shut down launches for weeks. Daily thunderstorms are guaranteed during summer months. Sea breezes create unpredictable wind conditions that affect both rockets and aircraft. SpaceX's solution involves operational flexibility that traditional space agencies never considered. Instead of rigid launch schedules, they want the ability to adapt to weather windows in real time. If storms block eastward launches, they could potentially launch southeast toward different orbits. But weather flexibility requires regulatory flexibility. Each different flight path needs separate environmental reviews, safety analyses, and airspace coordination. The bureaucratic complexity could take years to resolve and creates uncertainty for both SpaceX and aviation authorities. This weather challenge also affects the aviation impact calculations. Florida's frequent storms already disrupt air traffic regularly. Adding rocket launch closures to existing weather delays could create compounding problems for airlines and passengers. SpaceX's document makes it clear this isn't just about commercial efficiency, it's about American competitiveness in space. China recently announced plans for 100-plus rocket launches annually. Russia continues advancing reusable rocket technology. Europe is investing billions in space transportation. The country that can launch most frequently and reliably will dominate everything from satellite internet to space manufacturing. SpaceX is essentially arguing that America needs airport-style spaceports to maintain its leadership position. This national security argument resonates with government officials who worry about falling behind in the new space race. Fast, reliable access to space is increasingly seen as critical infrastructure, like highways or internet networks. But critics question whether concentrating so much launch capability at one location creates strategic vulnerabilities. A single hurricane, accident, or attack could potentially shut down America's most important space operations for months. Beyond the regulatory and infrastructure challenges, SpaceX is proposing operational innovations that could revolutionize spaceflight worldwide. Their vision involves multiple rockets in different preparation stages simultaneously. While one Starship launches, another could be fueling, and a third undergoing maintenance. It's assembly line thinking applied to rocket operations, something no space agency has ever attempted at this scale. This approach requires new technologies for rapid inspection, automated fueling, and real-time monitoring. SpaceX is essentially reinventing rocket operations from the ground up, treating launches like airline departures rather than rare engineering events. The implications extend far beyond SpaceX's business model. If successful, this operational approach could become the standard for space transportation worldwide, fundamentally changing how humanity accesses space. When could we actually see this transformation? SpaceX suggests they're targeting operational capability in the late 2020s, but the reality is more complex. Environmental reviews typically require 2 to 3 years. Regulatory approvals add another 12 to 18 months. Major infrastructure construction takes 18 to 24 months minimum. We're realistically looking at the early 2030s before this vision fully materializes. However, SpaceX has a track record of exceeding their own ambitious timelines when properly motivated. Falcon 9 went from experimental rocket to the world's most reliable launch vehicle in less than a decade. With sufficient regulatory support and infrastructure investment, Starship operations could accelerate dramatically. The key factor is political and regulatory momentum. If government agencies embrace SpaceX's data-driven safety approach and streamline approval processes, the timeline could compress significantly. But if bureaucratic resistance slows progress, the vision could take much longer to realize. This is exactly why Musk's Florida gamble changes everything. What we're witnessing isn't just SpaceX expanding operations. It's the birth of true space infrastructure. When rockets launch as routinely as airplanes, space stops being a destination and becomes a highway. The implications ripple far beyond Florida. NASA's Artemis missions, commercial space stations, asteroid mining ventures, they all depend on reliable, frequent access to orbit. SpaceX isn't just building launch pads. They're constructing the foundation for humanity's multiplanetary future, and this is just the beginning. Over the next 18 months, we'll see environmental reviews completed, infrastructure construction starting, and the first Starship test flights from Kennedy. By 2030, what seems impossible today could be as routine as catching a flight to Chicago. But here's what I want to know. How do you think this airport-style approach will change space exploration? Will other companies follow SpaceX's model, or will traditional aerospace push back against this disruption? This is Space Hub, where we break down the moves reshaping our cosmic future. If you want the real story behind space's biggest developments, you know where to find us. The age of space as a frontier is ending. The age of space as infrastructure has begun.